Good afternoon, and welcome to this next segment of the NISO interview series. With me today are Marjorie Hlava, President and Chairman of Access Innovations, and Heather Kotula, Vice President of Marketing and Communications, also with Access Innovations. Um, Margie is someone I've known for quite a while. She has a remarkable background. She was educated as a botanist and trained as an information engineer. However, certainly for the time I've known her, she's been president and chairman of Access Innovations, Inc. She has done tremendous service in the information community, having held board positions here at NISO as well as at NFACE, now folded into NISO, and the American Society for Information Science and Technology. She's received recognition numerous times from information associations such as SLA John Cotton Dana and SLA President's Award. She's also an SLA Fellow. She received an NFACE Miles Conrad Award in 2014 and is the author of multiple books and more than 200 articles, including the Taxo book, a 3-volume collection on the history and implementation of taxonomies. She holds 2 US patents encompassing 21 patent claims. We're catching up with Margie today to follow up on a talk she gave at the NFACE 2016 annual conference on the topic of artificial intelligence. So, Margie, first of all, let me welcome you.
Thank you.
To the NISO podium, and you as well, Heather. And I'm going to, at this point, turn over to the meat of our conversation. Let's start out with the way you started out that talk back in 2016. Are you still dividing artificial intelligence into those 3 categories of narrow, general, and super intelligence? Are those still the right categories for purposes of description?
They're still not bad. What we have, when I meant narrow intelligence, that was something that reflected a topical area. So if somebody's in cancer research, for example, that would be a narrow domain. It would be easier to build an artificial intelligence model for that, at least hypothetically. And there are a lot of diagnosis models, for example, in medicine. They form a decision tree. They existed in paper, and now they exist in electronic form. So those are fairly narrow. And then we have ones that are more general, but tend to enclose a broader domain, and so they're more for the general public. And they tend to, in my estimation, be question and answer machines. So Alexa and Siri, for example, would be fairly lightweight because they're answer machines. I don't know if anybody's ever noticed, but if you ask those things a question today, and it says, I don't know, and then you ask it a week later, they will know. They look at those questions and they harvest them and they build answers for them immediately. So those are general domain kinds of what we've been calling artificial intelligence. And then there are the super intelligent systems that actually try to do reasoning. And it's the reasoning part of artificial intelligence that remains the holy grail. We don't quite have many systems that do that very well, although there's a new one out, the GPT system that has been recently licensed by Microsoft. That is, to me, a very intriguing system, and we've just begun playing with it ourselves. So I can't tell you too much about it, but it holds some interesting promise. But as we see from other artificial intelligence systems, they're incredibly expensive to build. So this GPT is 2, and then there was GPT-3, and GPT-3 has 175 billion machine learning parameters, and every single one of those was hand built. So that's a very expensive proposition. You can hire a lot of humans. Well, they did hire a lot of humans to do that kind of work. But in general, narrow, general, and super still hold for me.
So I just like to provide a couple of examples. A self-driving car is still considered a general artificial intelligence. It just responds to a certain set of commands and parameters that are installed for it. When we think of super intelligences, there's a lot of science fiction that comes into play. Like the computer in Star Trek would be a super intelligence, or HAL from the Space Odyssey movie. So we're firmly in the stage of having functional, general artificial intelligences. True super intelligences, I think, are still in their very beginning stages.
Yep, I would agree with that.
Well, in 2016, I'm going to refer now to that talk you gave. You had specifically said that, and this is the quote, it said, Moore's law said that technology change doubled every 18 months. Now the hardware changes are not moving as quickly, but the software implementations are diverse and exploding. Has that changed in the past 5 years? Are new software implementations emerging, or are they simply less visible being under the hood?
So there are an awful lot of, Moore's law really had to do with hardware. And I think Heather will be itching to chime in on this one because it's one of her hobby horses. But it's a law that says that every 18 months, everything doubles. But actually that time got very short, got much shorter than every 18 months for a while. And now it's not the hardware, it's the software. We have an incredible number of tools available now for helping people build out software. There's huge libraries in Java, and that's just one example, that are already pre-written, and you can cobble those together to make all kinds of new applications very quickly. And so I think that Moore's law for hardware, yeah, I think that's kind of slowed down, but Moore's law for software, yeah, that's pretty strong still. Heather, what do you want to add to that?
So Moore's law is not so much a law as a prediction made by Gordon Moore early in his days of founding Intel. He predicted that they could make chips half the size and twice the speed within every 2 years. So they'd be having the size and doubling the capacity every 2 years. They did shrink that to 18 months, and that was a notable accomplishment. And they've got it down to, I think at one point, I think it was actually just a year. But we're talking hardware here, we're talking chip manufacturers, and they have encountered a problem with the basic laws of science that ultimately chips are made up of molecules and atoms. And at a certain point, they just can't get any smaller. I believe the most recent research shows that they're working on a 14 nanometer chip. And the problem that they're running into with the chips getting so small is heat. The heat of those chips firing is causing them to melt down. And when they were much larger, there was a much more capacity available within the hardware to put in cooling mechanisms. But now the heat generated by these that are so small, so as the size decreases, the heat output increases, and they're having trouble finding enough cooling for it. So I think software applications absolutely have to keep pace. One of the things that I think we all know is that when at the dawn of the computer age, space was very limited and very expensive, and connectivity was limited and also expensive. So we spent a lot of time condensing data down to its basic elements. And then, professional searchers would retrieve that information for somebody else because they understood the syntax and how the information architecture worked. So then Intel came along and the other manufacturers, and they gave us enormous amounts of storage and very fast processing speeds, and connectivity and communications have blossomed so that what we're doing right now, real-time messaging, real-time video, we don't even think about how it works. The pitfall to that is human behavior. We said, oh, we have this huge playground, so we're just going to explode the amount of data and information we have and not worry about curating it and tagging it and making sure we can find it again later. We'll just do a full text search. So both software and services having to do with adding to that information, enriching that information so that it can be retrieved later is a huge issue. The other day we were just discussing the coming of age of taxonomy. I think broadly speaking, many content producers are finally realizing that, yeah, this is really a thing because we can't find anything anymore.
We take so much of the technology for granted. It's really quite interesting to hear you explain where the real issues are in terms of the hardware and the heating, and it's it's quite striking how
Well,
much.
it's like going back to your first question, Jill, about the narrow versus general versus super intelligence. And another way that that could be stated is there's knowledge, and then there's learning, then there's knowledge, then there's intelligence, then there's wisdom. And we certainly have not gotten to the wisdom side, even necessarily in regular people, but it takes a super intelligence to be able to gather that level, whereas the artificial human intelligence is aiming, or general intelligence is aiming to be as smart as a human and being able to problem solve and do complex thoughts and so on. And so far, those are all like in that GPT system, reasoning based, and somebody has to set out those parameters. So we go back both in the case of Moore's law and the cost of the real implementation cost in the chips is the heat generated. We have to have some way to control that. So it's the tactical aspects of things that hold us back and make us having to think hard about how these implementations going to work for us.
There's a strategic aspect too, in that we, as a race of humans, still don't really have a very good understanding of how human intelligence works. So the question is, how can humans expect to teach a machine how to learn and how to be intelligent if we don't understand how we do it ourselves?
That's right. I was at a meeting some years ago at Los Alamos National Labs about artificial intelligence and the frontiers and the intersection of artificial intelligence, translation, and other things that can be done mostly programmatically. And a guy from Cray was there. Cray was a great big computer manufacturer. And he said that as soon as it was available, he was going to get a 5 megabyte chip installed in his head that would run off the body chemistry, because that's how much core space there was calculated to be in the human brain. So in 5 megabytes of storage, he'd be able to double his mental capacity and double his reasoning. I don't think it's happened yet.
Well, that that kind of brings us up to again IBM, something that was big in 2016. At that point in time, IBM Watson had just been on Jeopardy, competing with two adults. And it was one of those instances where you really wanted to see how the humans would compete with the machine and what did this mean for us in terms of artificial intelligence. And in 2015, 2016, when it was shown, the perception was that IBM Watson represented a tremendous step forward. It's again 5 years later. What has happened with IBM Watson and that form of artificial intelligence?
So Watson is a dictionary machine. They loaded a ton of stuff, everything they could. I mean, they dumped in the Encyclopedia Britannica, and they dumped in all of Wikipedia, and they dumped in every other fact-based system that they could come up with. And then they ran it as it looked like on the screen, a picture of a computer CRT interface, and then they had the two guys, Ken and Brad, on either side of on the other podiums. But behind the scenes in the next room, the real IBM Watson was 90 IBM servers, each of them with 8 core processors, each of those with 4 sets of CPUs and 32 processors per box, with a total processing power of over 80 teraflops, which is 1 trillion apps per second that they were running, just running. And that was okay if it was a yes, no, or fact-based answer. But when they tried to apply it to reasoning engines, like for medical implementations, they had a massive flop down at MD Anderson in Houston. They implemented an IBM Watson system, and after many millions of dollars, abandoned the project as something that absolutely wouldn't work because it couldn't answer and it couldn't diagnose, and it was not replacing the physicians or even making them more efficient. And since then, I think IBM has really floundered a bit with the IBM Watson system. They wanted it does many things, but they wanted it to do a step beyond what it was capable of. It is not a super intelligence machine. It's just a general answering machine.
Can you talk a little bit about how it compares with Siri and Alexa? Is it the same type of rationale?
Yeah, it is. Siri and Alexa have a voice translation system at the front end. Usually it's Dragon, but it could be a number of other software products. So it listens to the thing that a person said. It parses those into a sentence structure. Normally it's a question structure, so they're looking for an answer to a question. Or it might be a request. So Siri, play me Beethoven's Fifth or something. And then all you need to do is focus on the phrase Beethoven's Fifth and then cue it up from the library. It's the same thing for IBM Watson. If somebody says, what's the population of China? They just look up in the dictionary and say, well, the population of China in 2020 was estimated at blah, blah, blah. And so there's 3 pieces to that system, which then appears to be human. One of them is something that takes in voice and translates it to text. And then that text translates into a computer query, just like we do in search. and the search engine brings back an answer to that query, which is then translated to voice with some syntax around it that's fairly standard, just like the map app in your Apple Maps or Google Maps. That's a whole series of little things that are strung together programmatically and presented to you. They're a lot of work to create, but they're wonderful to use. They're still not super intelligence. They're just general systems.
Heather, you started to say something, I think.
Yeah, so in 2016, when IBM Watson was on Jeopardy, it was really basically just an answer bot. And like Margie said, it's massive computing capability, accessing an enormous database of facts and using algorithms to create the questions and then respond back as, or look at the answer and respond back as a question in the Jeopardy game show format. And then in the article in 2019 with the MD Anderson Cancer Center, I believe it was $63 million that they put in over the course of 2 years to try to get IBM, to get Watson to diagnose cancer issues. And in the article that came out about it, if you read down far enough, the developers actually finally admitted that it's not using a lot of cognitive computing and machine learning techniques. Instead, it's a rules-based system. They had thousands of people building rules based on those facts in order to make it work and look like a super intelligence. But in the end, it was not what they were originally trying to make us believe.
Yeah, they couldn't meet the contractual obligation. And with that failure, it pretty much hurt the future prospects of the Watson implementation. Although we do watch with great interest every time Watson makes an acquisition, and they've made a fund, or IBM makes an acquisition for Watson, but they still haven't done any purchasing of true reasoning engines. And with our own software, we use a rules-based system, but our rules are different in that the rules that they were writing for Watson were all SQL rules, which require programmers, and they're expensive, very expensive to implement.
Not that we want to be Watson bashing. We're not. There are a lot of things that Watson does very well.
It has an incredible dictionary, biggest in the world.
Well, I think the other thing about it is that we are becoming used to systems that we engage with. We're not necessarily familiar with how they operate under the hood, but I turn to Alexa, I ask it, what is the news in Philadelphia today? And Alexa gives me the headlines. That's still a tremendous step forward from where we were at the beginning of the 21st century. So it agreed, we're not here to bash IBM by any stretch. It's just a question of determining where we really are at this point with artificial intelligence.
Right, and have we reached a reasoning system or an ethical system or any of those kinds of things? You know, you inferred very early about Hal in 2001, and when he said, "I can't do that," meaning that he was basically terminating the life of the human, they unplugged it.
So everybody has one of these in their pocket, pretty much. And the texting app has an artificial intelligence system built into it. So as you're typing in a word, it will do type ahead, which is just type ahead. But then it will offer you, and it'll offer you spelling suggestions that you can just click on and stop typing. It will also then offer you what it thinks could be the next word in the phrase or the sentence that you're trying to type. And just in case you're interested, that's an example of a Markov chain Monte Carlo method algorithm. So little things like that, but that's again, that's a general intelligence. It's not actually interpreting my thoughts or learning from my behavior. It's just looking at the patterns that I do. It's a statistical based model. So it's just looking at the patterns of my behavior, because pretty much every night I send a text saying dinner in 5 minutes to my teenage daughter who's upstairs. So they don't have to be huge and complex and or anything like that. You know, I think most of us are carrying an AI system in our pocket.
So we
Here's what we-
largely established what artificial intelligence is in a very general sense. If we can bring it down now more towards the specifics of the information community, what are content providers doing now with artificial intelligence? Can you talk a little bit about what you see?
Well, they are applying subject metadata so that they can disambiguate the text, which gives them a good semantic equalizer for organizing the information so that it can provide those services, much like the services of the Watson or your telephone. So the basics are there when you have all the synonymy in place and you have figures of speech organized so that they can be disambiguated. So a lot of publishers are doing that kind of stuff. They are beefing up their subject metadata or the content enrichment in their systems so that they can take advantage of the word type of things, so that when the data is bubbling up in the search system or in the whatever kind of query mechanism they're using, they know that horses and equines are the same thing, so that they can get a lot of normalization in the topic that they're talking about, and that gets them to a good basic level for implementing AI. If they move one step further and they tag all their data so that it has some sort of in content enrichment tagged to the metadata, then that allows them to use logical reasoning and rules to present the data to their user base. And then the next level would be search and discovery, where you leverage that word base and you can use it in personalization or visualizations or just plain search. And I would say that a tremendous number of content providers are well on the road to making that shift.
And what will that look like in it for the user? What might they then be able to anticipate?
Well, so say I go to my computer and I ask it for the Mayo website, and I say, tell me about the symptoms for a spine nodule or some kind of a problem. They're having back problems, and I think it might be a spine nodule. Or tell me the symptoms of a kidney stone, and it'll tell you those symptoms back again, and you can have a conversation based on their topical content about questions that you have. I might go to an engineering site and say, give me the approximate definitions of the span or tensile strength of a bridge, and tell them the name of the bridge, and it'll come back to you with that information, because that information is tagged and coded behind the scenes. If it's not tagged and coded, the system's not going to be able to give you back that answer.
So what pitfalls are there that those individuals building these systems should be aware of, and what should they try to avoid?
Well, if you get the if you're word-based, your concept organization or categorization is too narrow and does not include a lot of colloquialisms and misspellings and other things. You're going to miss a lot of input content, and you're going to miss a lot of things that people ask for. I mean, Heather was showing you the telephone, and I have to tell you that I use the dictation a lot. But my family will say, did you proofread that before you sent it? Because it really interprets a lot of things in ways that I didn't want them stated. And if I'm not careful, I've noticed that because it's in widespread use within the training set that these companies use, it'll have swear words in there and things that I really didn't mean to say at all. So I caught one the other day when I went, I do not use that word, not ever. When people say it, I feel like I've been socked in the face. And there it was in my text, and I'm going, holy cow. So you have to be really careful both on the input and on filtering, particularly if it's a voice system, filtering the input and to either say, did you mean? And prompt the user back again to make sure that they were asking what they thought they were asking. And also make sure that the input text is clean, particularly if it's multilingual. So we get one of the things we've been working on lately is merchandise accounts, retail ordering systems for some Latin American markets. And they're in Spanish and Portuguese and English. And so some of the cognates from one, when translated into another, means something radically different and not something that polite company would ask for. So you just need to be very, very careful and sensitive to those marketplaces and toward the linguistic differences.
Margie, I think I may have heard you use that word twice in all the years I've known you. Those were remarkable times. Some of the pitfalls that come to my mind, dirty data. If your content is messy, you're going to run into some issues. And if your data is unstructured or in multiple different structures, you could end up with some problems. Data in AI, we talk a lot about modeling and uncertainty. And when you're running training sets, you put in a data, you start with a data dump and you look at the results. And then you're likely to want to tweak your results or tweak your model so that it better fits those results so that the next training set shows a better, it has a better outcome. What the pitfall here is altering your model so much that it no longer actually represents the data. And we've seen this happen before. You get so far off of, you can imagine things as points on a graph and a line going through them is your model. And you want to incorporate, these points here. So you change your model and then you run another training set and then you have to change your model more. And then you have to change your model more with each successive training set until you get to the point where your model just doesn't make any sense. And what you've got is just garbage coming out. One of our data science, Dan Vasicek, wrote a white paper on this in the KM World publication, I think about a year and a half ago. And it's a very good paper if anyone's interested in looking at it.
So, Heather, a couple of tangential points to that. One is the misnomer of unstructured data. When we talk about structured data, we really mean fielded data, but an awful lot of data that's considered unstructured really isn't. Word documents, for example, or PDFs often have a lot of inherent structure in them. It's not XML, but it's still structure that you can build from. And what is increasingly popular to be talked about, but not particularly implemented, are the companion pieces of triple stores and knowledge graphs. And those are very pretty and they spin really quickly, but they are really verbose and intensive in terms of implementation. They take a lot of computer space to make them happen and have not been particularly well implemented for big data sets as yet. That's another one of the pitfalls I think that we face. We chase the newest shiny object, and it's not necessarily taking us where we thought we were going to go. So one of the things that article that Heather was indicating by Dan Vesicek is it talks about something called overfitting. So what happens is people try to make it more and more elaborate, and pretty soon it spins way out of control. And we've seen this recently in a lot of models, the original models on COVID, for example, the predictive models. The base assumptions were just assumptions. We didn't have any data yet. And the people who made those models freely admit that that's a challenge. They didn't know what, and so they guesstimated how many people would infect how many other people and how many people would die with a month's worth of data. And they were fine and they were willing to change their models, but a lot of other people took their models and built on those models to get some astonishing results that, looking back, are way off the mark. And the same is true in climate change, for example. The original climate change model has been proven to be inaccurate. And those guys have built new models that are very good, but the original models are often republished and re-referred to, and so we get models that spin on models that spin on models, and the results are not very good. And that is a major pitfall of this kind of work and the modeling for it. If you try to model human intelligence and you put in a set of ethics based on the thoughts of John Locke and what he published originally, and then you take another set and you put in the teachings of Marx and Lenin, you get an entirely different set of information and feedback based on the same set of core data, but entirely different models applied to them. And that is a concern, because who knows what's right?
Well, so much of what we're seeing can only be explained over time. I mean, you've, as we've seen with the pandemic, what you think you're starting out with initially may be very different over the course of time.
Yeah. As the information evolves, we're learning a great deal more, and we need to be able in these models to feed in the new information and keep updating the model, as opposed to building on a model that turns out to be flawed because the initial information we had wasn't quite right. And we wouldn't have known that when we got started. There was just no way to know.
So what might content providers shoot for in their strategic planning for the next 5 years?
Well, from my point of view, it's a really good time to get your data well organized and enriched. I mean, get it all to the same level of coding, get a tagging started on it. It can always be added to. People used to think, oh my God, I can't rerun the back file. But you know, nowadays with the level of computing that we have, you can rerun your back file in a matter of hours, even if you have millions of documents. So that is no longer a concern, and we don't have to worry about constantly updating and putting patches. We can just tag it to the best of our ability, and then if we need to rerun it, tomorrow it'll be ready again.
Well, that sounds very encouraging.
Yeah, I think people have locked themselves into the, oh my God, it's a complete system rewrite. No, it doesn't have to be a complete system rewrite. It would be a mistake to build your system that way.
Well, I want to thank you both for your time today. And I know that we'll see you in 2021 at the NISO Plus conference virtually, but it'll still be great to have you there with us as well.
Thank you very much, Jill. It's been fun.
Yes, and we're looking forward to the next things that will happen with NISO. It's perfect. Thank you.
Well, thank you for your time here today.